Okay, hopefully this is going to be a review for you, but we're going to talk about trigonometry. The most important thing you will write down is going to be up here, and we're going to put this little symbol right there. Let me stop and explain what that is. It's a zero with a hyphen through it. It is a Greek letter. That Greek letter is known as theta. So over here on the side, I'm going to go, this is theta. It is used to talk about angles, used to denote angles. If you look ahead, look at the pictures, you'll see the theta is here and here. It is the measurement of an angle in degrees, or the other way that it's measured, which is radians. We won't talk about radians in this lesson, but it will probably occur at some point in the near future. So, sine of theta, cosine of theta, and tangent of theta. They don't look the same, do they? My thetas are a little different, but it's no big deal. Sine of theta equals, cosine equals, tangent equals. Okay. Most important thing you will write. Opposite divided by hypotenuse. You have seen this before. You have probably heard the phrase SOHCAHTOA before. I'll explain what that means in a second. Adjacent. Over, and I'm going to throw in an extra word right here. Adjacent leg, because people get confused about that, over hypotenuse. And tangent is opposite divided by adjacent leg. And if you wanted to, you could say it's an opposite leg, because the two legs meet to make a right angle. So this is a leg and this is a leg, and that's the hypotenuse. Okay? Well, now that we're already identifying things, let's keep going. Now, when we talk about opposite, hypotenuse, and adjacent, we are going to go in reference to the angle that they are mentioning, whether it's a theta or whether it is an actual degree measurement or something like that. But this is our angle. So let's start with the obvious that has nothing to do with this angle. It has everything to do with the right angle. This guy right here is the hypotenuse. I'll label him in blue. You, Mr. 17, are the hypotenuse. I will abbreviate it HYP. This should go pretty quickly for you because, like I said, you've seen this before. But now, in relation to this theta, to this angle, this little corner right here, what is this side? Is it opposite this angle, or is it adjacent to this angle? Now, adjacent means side by side. So this side, this leg, is beside that angle, therefore it is adjacent, and this one is opposite. Opposite meaning it's across from. Like if I was to take that angle and fire a rocket from it, then it would eventually hit the opposite side. Okay? So, we're going to write down three things. We're going to write down the sine of theta, we're going to write down the cosine of theta, and we're going to write down the tangent of theta, and we're going to do this very quickly. Knowing that sine is opposite over hypotenuse, we'll just come up here and we'll go, well, sine is opposite over hypotenuse, so it's 8 over 17. There we go, 8 divided by 17. Alright, the cosine is the adjacent leg divided by the hypotenuse. The reason I threw the word leg in there is because some people will just briefly look at this side and say, well, it's next to it, it's the adjacent. No, it's the hypotenuse. So it has to be the one that's adjacent to it that is the leg. Just the one that is in there, okay? Anyway, adjacent leg divided by hypotenuse, that would be 15 divided by 17. And the tangent is going to be opposite divided by adjacent, 8 divided by 15. There we go. We just set up those three, big word, trigonometric ratios. These are the three trigonometric ratios for this triangle right here. We're going to do the same thing for this triangle, which is the same triangle, but notice that we have moved theta. It is now in an opposite, well, it is in a different corner. It is actually in the opposite corner, but opposite in this sense means something slightly different because we're talking about sides. So again, let's state the obvious. This is the hypotenuse. Hypotenuse is two things. It's always the longest side in a right triangle, and it's always across from the right angle. Okay, so in relation to this angle right here, this theta that's been marked off, what is the 8? Ah, it is adjacent to it. Good call if you said that. This is adjacent, then that leaves only one option. The one that is across from it is opposite from it. If I'm opposite the room from you, then I'm not touching you. Unless it's a ridiculously small room. So if I am opposite this angle, then they don't touch. Alright, so let's set this up. You can see where I'm headed with this. Go ahead and write it down. You don't have to wait on me. Sine is Looking at the top, opposite over hypotenuse. Opposite over hypotenuse, that is 15 over 17. Cosine is adjacent over hypotenuse, that is 8 over 17. And tangent is opposite divided by adjacent, which is 15 divided by 8. I want to take just a minute here and talk about a few patterns that you will see that will appear again, okay? I'm just going to write down a few things that are going to come in kind of handy in the weeks to come. Look at this number, this fraction right here. 8 divided by 17. Is it bigger than 1 or less than 1? 8 over 17 is less than 1. Cosine is 15 over 17. Greater than 1 or less than 1? Less than 1. Let's ignore tangent for a second. Less than 1. Less than 1. Sine. By the way, it's abbreviated by the first 3 letters, but you probably figured that out by now. Sine and cosine are always less than 1. Always, if it is greater than 1, you done messed up. Now, tangent can be bigger than 1. This one is not. It doesn't have to be bigger than 1, but it can be bigger than 1. And there's probably something else that you more than likely noticed, and you're waiting on me to say it, so let's go ahead and just address it. These are the same triangle with the angles marked in different angles. So like this one's in this corner, this one's in this corner. And doing so swapped around some of our answers. So when you have the same triangle, but you've moved the reference angle, the one that you're dealing with, then sine becomes cosine. Notice these are the same. And then cosine becomes sine. Okay, that's just one of those little things. Tuck it away. It's going to come in handy in a few days or weeks. All right, let's slide this thing up. Ignore my scribbles down here. Those are the directions for the next section. They're actually not on your paper. Yours has been corrected. Okay, we're going to solve for x, and the best thing we should do, and I'm just going to tell you the steps first of all. What you need to do is try to figure out what type of problem it is, and for all of these in this lesson, it is going to be right triangle trig, because that block means it's a right triangle, so you got it. It is right triangle trig. Later it will not be that easy, but for now, you see triangles, they're right triangles, so we're going to go for it. Step 2, try to figure out what is opposite, adjacent, and hypotenuse. I always start with a hypotenuse personally. So in this triangle, this little guy right here is the hypotenuse, which actually is the most useless information I could possibly write, because this hypotenuse, this side right here, is not labeled with a variable or a number, so we're never going to use the hypotenuse, but we are going to use this 16. In relation to this 23-degree angle, what is this 16? It is adjacent. Good answer. All right, that leaves only one option, but it's this x right here is opposite. So, knowing that we have an x and a 16, these two sides are labeled, and we never were dealing with the hypotenuse. We have to deal with the opposite and the adjacent. We come up here and we look, and we ask ourselves, hey, opposite and adjacent, what's that? Well, clearly it's tangent. If I would have said adjacent and hypotenuse, you'd have picked cosine. If I had said opposite and hypotenuse, you'd have picked sine. The two sides that you have labeled are going to determine which of these trigonometric functions you pick. We're going to pick tangent because opposite and adjacent were labeled. Now one of them was a variable, but it was labeled. So the tangent of 23 degrees is equal to opposite, which is x, divided by adjacent, which is 16. Grab a calculator. This is one of the most important things I will say. The thing at the top was the most important thing to write. This is the most important thing I'm going to say. You will miss every single problem unless you do what I'm about to do. More than likely, unless your calculator is already magically set, you're going to miss it. So follow me closely. Every time you start to do trigonometry problems and everything is in degrees, you have to do this. This is so important. I'm going to say it one more time. Every time you're starting trig problems, do this. Press mode. We are not in radians. We are going to be in degrees. So go down and set it to degrees. This paper is in degrees. Your calculator better match it. There we go. You are now in degrees. Otherwise, all the trig junk you typed would have given you an answer in radians, and it would have been way off. Okay, we need to find out what x is. I'm going to go ahead and solve it because y'all are juniors and seniors in high school, and I would love to take you through this very slowly and bore you to death and say, let's find the tangent of 23. Now we'll multiply by 16. Yay! Yeah, we're not going to do that. We're not going to do it. We're going to go ahead and treat it the way the good Lord intended it to be treated. We're going to multiply by 16 from the very beginning, put a 16 in the front. We're going to type that entire thing in the calculator and save ourselves some steps. This guy right here is about to get typed in. Now you just saw the answer a second ago, but here it is. 16 times the tangent of 23. Boom, 6.79. 6.79 what? I don't know. It wasn't labeled as feet or inches or anything else, but there it is. Okay? The calculator will tell you what that is. The rest of it, you just solve like an equation. Number 2. Alright, let's not label the thing that's not labeled. In other words, I don't care what this side is. I don't care if it's opposite, adjacent, hypotenuse. I don't care. There's no variable, there's no number. Who cares? But what's this? Boy, I hope you said what I thought you were saying. Alright, what's this? Good. Alright, you have a hypotenuse and adjacent. Hypotenuse and adjacent is what? Sounds like cosine to me. Alright, the cosine of 76 degrees is adjacent over hypotenuse. Make sure you put them in the right place. That's going to come in handy in a minute. If we were going to solve this equation for x, don't let that guy mess you up. We'll deal with him in a second. But if you're going to solve it for x, you'd multiply by 15. You'd put a 15 in the front, and x would equal whatever that is. Type it all in at once. Don't waste your time typing it in one little step at a time. You're an AFM. You're a big kid now. Type it all at once. 3.63. Feet, inches, I don't know, yards, meters, parsecs. It's a way for measuring distances in space. P-A-R-C-E. P-A-R-S-E-C-S, I think. It's irrelevant. Here's number 3. Alright, I'll point. You figure out what it is. When I'm pointing, you should have a word in your head. It should be opposite, adjacent, or hypotenuse. Let's start here. I always start there, don't I? Okay, well, what's that one? There's 2 answers. It's adjacent and it's irrelevant. Who cares what this is? We're not using it. We don't know it. We don't need it. What's that? It is opposite the angle that we're dealing with. It is across the triangle from the angle. So therefore, we will set this one up. If you're slightly ahead of me, be careful. Make sure you're writing this correctly. Opposite and hypotenuse is what? Sine? Sounds good. Sine of 23 degrees is equal to opposite over hypotenuse. This one is different. That's why I told you to be careful a second ago. Because we get in such a habit of putting the x in the numerator and the number in the denominator, and this one is not that way. It is not. So how do we solve this? There's 2 methods, but they're really the same thing. I'm going to go at it from the standpoint of cross multiplication. Put a 1 under that, and you can cross multiply this thing. The other idea is really just to multiply by x, which is the same thing. But let's cross multiply. 1 times 16 is 16. When you cross multiply, the 2 things you multiplied are equal. 1 times 16 is 16. X times that, I don't know what that is, but that's okay. I'm just going to write it anyhow. Okay, if I wanted x by himself, I would divide by the sine of 23. Whatever that is, my calculator will tell me in a minute. So divided by sine 23, and we're going to cross those out. We divide them out. 16 divided by the sine of 23. Let's close those parentheses just for good luck. X equals, I'm a 2 decimal place sort of guy, so 40.95. There we go. And that is the front side of your notes. I'm going to try to go ahead and squeeze the back side of the notes into the same video. So if you will flip your paper over, you will see 6 more problems. I'm going to go kind of quickly through these next 3, and then I'm going to hit the word problems a little bit slower. Okay, pause it if you need it. Alright, your directions say solve for theta. So now it's going to get a little bit different. So when we're solving for theta, what we need to do is find out what the angle measurement is. It's going to start the same, actually. It's going to just kind of be the same process at the beginning. So in relation to this angle, what is that side? What is it? Opposite, adjacent, or hypotenuse? Boy, I hope you just said that. Okay. What's that one? Hope you're right. Okay. So far, all of our triangles have been facing the same direction, pointing in the same way, which is not really conducive to you understanding that they can be turned around. When we get to the word problems, I'm going to draw them all kinds of crazy ways. Okay, if you have opposite and hypotenuse, which one would you pick? Which trigonometric function would you pick? Well, let's do it. Tangent of theta equals 4 over 13. Well, how do we solve that? Well, we solve that. Just like we've solved other things, we're going to solve that, meaning we do an inverse operation. Let me show you. Just a second ago, we did an inverse operation. The inverse of multiplication, the inverse of division was multiplication. The inverse of division was multiplication. The inverse of multiplication was division. We would do an inverse operation. If this said plus something, you'd subtract something. Well, what's the inverse of tan? It's actually, I just told you the answer. It's the inverse of tan. I'm going to write it out in good, big, fancy mathematical language. It's the inverse of tan, and you've seen that notation before. It's inverse tan of theta equals inverse tan of 4 over 13. Don't make that cause you to panic. It's not that big a deal. Do you have to write that every time? No, but I'm just showing you that these are inverses of each other, and for the same reason that I can come through here and be like, I'm going to cross those out, because they cancel each other out in their little inverse kind of way. Those right there undo each other, and I'm left with theta equals that. Long story short, when I am looking for an angle measurement, I use an inverse function, which in the calculator looks like this. Second and tan, and that little thing pops up, and then just type that fraction, 4 over 13, and there we go. Most people round these to the nearest whole number, because when you're talking about degrees, you don't say 17.1 degrees. I mean, you can, and you should if you want to be really exact with it, especially if you're in engineering. Generally, though, people will just say 17 degrees. So I'm going to just go to the nearest whole number. If you don't, that's cool. But I'm going to go 17 degrees. There we go. All right, let's do the next two real quick because I think you got this. I point. You mumble to yourself what the answer is. You should say opposite, adjacent, or hypotenuse. Go. All right. Hope you said that. What's that one? Did you say that? Then you'd be wrong. Haha. I hope you didn't write that down because you know better. That's opposite. Okay, which one of them is opposite and adjacent? You grab your paper, you flip it over, you look at the top. In a minute I'm going to tell you how to memorize those. Opposite and adjacent would be tangent. This guy is tangent. You know what? I just did the last problem wrong, and I'm not going to undo this video. I'm not. I'm going to come back and fix number 4 in just a minute. I'd hate to start this video all over, but I just did number 4 wrong, and I am so sorry. Because you're probably thinking, what? What was that? Let's go ahead and fix this one. Let's go ahead and do this one. Tangent theta equals 8 over 4. Man, that's bothering me. I done messed up. Y'all probably noticed it long before I did. That's right. You can have a math degree and still make mistakes. Okay, if you're solving for theta, you would do the inverse tangent of 8 over 4. There we go. Inverse tangent of 8 over 4. Well, obviously that's 2. And you can type it as 8 over 4, but my word, you know what 8 divided by 4 is. So inverse tangent of 8 over 4 is 63 degrees. Okay, learning opportunity. Before I move on to number 6, what did I mess up on number 4? Did you notice it? Did you notice it? I screwed up pretty bad. Real bad, actually. I hope you saw it. Opposite and hypotenuse is not tangent. It's sine. Oh my word. I am so sorry. But you know, sometimes when the teacher makes mistakes, it causes people to think a little bit harder. So I'm going to, like I said, I'm going to leave it in the video. Plus, I don't want to back up and do the whole thing again. So this normally was sine, which means that this would have been inverse sine of sine, they would cancel each other out, which means that this is the inverse sine. Boy, I am making a big sloppy mess, aren't I? Big old mess. Woo! That's awful. Let's fix it real quick though. Inverse sine of 4 over 13, and that is 17.9 degrees. So actually I wasn't too far off in my final answer, which is just a pure coincidence, 18 degrees. Okay? I'm sorry about that. Alright, number 6. Let's see if I can do this one right. Hypotenuse. Adjacent. Okay? Good? Hope so. Boy, I hope I'm good. Which one is this? I better be careful. Hypotenuse and adjacent is what? Cosine of theta equals, now again, we're looking for the angle measure. When you're looking for the angle measure, which is usually a Greek letter, not always, but usually a Greek letter, then you're going to need to do an inverse operation, meaning final answer is going to be whatever this is right here. It's the inverse cosine. You know what that exponent of -1 means. It means inverse. You've seen it before. Okay? Inverse cosine of 4 over 13. Can I go ahead and tell you the answer before I hit enter? I'm just dying to tell you the answer before I hit enter. And I'm going to tell you how I got it too. The answer is 72. And no, I didn't type it in my calculator while it was off screen, off the video. 72. Here's how I knew that. I just want you to start thinking of little tricks like this. Look at these two problems. They are exactly this. I've seen this before. They're the exact same problem with the angle in a different place. Well, and you got this. You got this. If this is 18 degrees and this is the same triangle, then this is 18 degrees. How many degrees are in a triangle? In a perfectly flat triangle, actually called Euclidean geometry, if you want to get technical about it, in a flat geometry, you have 180 degrees in a triangle, so I went 180 minus 90 minus 18, did that in my head, I got 72. I knew that was 72 because I already knew that was 18 because I knew these were the same. It's kind of looking back. So it's just one of those little things. Keep an eye out for that kind of stuff. Okay, 3 more problems, and the hard part about this isn't solving them, it's setting them up and drawing them. And that's actually the fun part too. You are lying on the ground 45 feet from a tree. Stop right there and draw it. Okay, here's me. I'm lying on the ground. Actually, the fact that I'm lying on the ground is important. If I was standing up, then I would have to take my height into consideration, and the problem would be a little bit trickier. I'm laying on the ground, so here we go. I'm laying on the ground. Here's a tree. Don't make fun of my tree. It's not going to look pretty. That's awful. It's got a little hole in it. There's an owl that sleeps there every night. Who? An owl. That was a joke. Who? Get it? It's an owl. Never mind. Okay. The angle of elevation. Let's just stop right there. When you get in an elevator, what do? You go up. Now you could go down too, but elevation means up. So elevation. We're looking up. If you see the word depression, it means down. If you're depressed, you're feeling down, obviously. So the angle of elevation is when you look up. Angle of depression is when you're looking down. Just want you to know that. It's kind of intuitive. Angle of elevation is you view the top of the tree as 69 degrees. So this angle right here, boom, as I'm looking up, is 69 degrees. How tall is the tree? Well, how tall is the tree? I don't know, and because I don't know, I'm going to call it X. Now, if you look real close, you've got a right triangle going on right here. If you wanted to, you can draw that little box. There's one thing I haven't labeled, but I think you know what it is. I'm lying on the ground 45 feet from the tree. Now, let's think about it logically. What's 45 feet? Is this 45 feet? No, that's not 45 feet. Otherwise, I would have known how tall the tree was. Is this 45 feet? No, that's not the ground. When I talk about being so far away from a tree, I'm not going to be like, I was 45 feet from the top of the tree. No, that's not even logical. 45 feet down here. Okay, if it helps, you can draw a little triangle just to kind of make it less picturesque. That's 45. That's 69 degrees. In relation to the angle that we know, you can barely see that. Same thing over here, but sometimes I like to draw it again just to take the picture out of it. Take the tree, take the person, you know, and you have just a triangle. All right, in relation to this angle in this corner, what is that? That would be opposite. This would be adjacent. Okay, I'm going to not talk as I finish this problem. I'm going to let you do it. Please, please, please look away from your screen and try to solve it on your own. Don't look. There we go. Am I done? Yeah, yes and no. Just something that I want you to get in the habit of doing. Because they told you that it was feet, put that there. Am I going to count off for that? I don't know. We'll see. I'll let you know either way. But do get in that habit. Okay? Number 8. 25-foot ladders leaning against the side of a building. Just stop right there and draw it. Here's a ladder. Now, don't draw your ladder vertically. It's leaning. Make sure you're reading the problem correctly. There's this ladder. It doesn't have to be perfect. Obviously, my ladder's not perfect. There's some rungs that aren't even connected on mine. See, look, don't step on that rung right there. You'll fall right through. Leans against the side of a building. Well, better have a building. That building better be straight. Mine looks kind of crooked there. And obviously the whole thing's sitting on the ground. Now, obviously also you have a right triangle going on, and he's right here. We don't need this building. You don't need that window. You don't need all that stuff right there, but I'm going to draw it anyway. There's a little door. Lets you right in the building. It's a 3-story building. There's a guy up on the roof. He's wearing a hat. Great big hat. There we go. The ladder makes a 74-degree angle with the ground. Okay. 74-degree angle with the ground. Well, clearly the building's not leaning. We're going to go on that assumption, which makes it a right angle. 74-degree angle with the ground. Is that here? Or is it here? Now, there's an obvious answer to that, but be careful, because I've seen a lot of students put the 74 up here because they didn't read carefully. This is the ground, this is the ladder, and they make a 74-degree angle, and I'm not insulting your intelligence, but please read carefully. One number I left out, it's in the first sentence, 25-foot ladder. I'm going to ask a series of dumb questions. Is that 25? No, that's not the ladder. Is that 25? No, that's not the ladder. Clearly this is 25, and it is 25 feet. All right. Then the question is, how tall the building does the ladder go? It is asking about the height of the building, well, up to the ladder. So, boom, it's asking for that. Not going to draw this one again. I'm just going to go based on this. From this triangle, using this angle as a reference, what is this? That is the hypotenuse, regardless of our reference angle. This is opposite. Again, I'm going to solve this very quickly. Please do it on your own. Pause it if you need to. Try not to watch. I want you to be able to do this on your own. I'm done. Pause it if you need more time. I went very quickly through that just to keep this video short, even though it's ridiculously long already. I'm going to move on. Okay. Pause it if you need to. Number 9. A 70-foot tall telephone pole, the ground, a pole, it's 70 feet. We'll just go ahead and start drawing things. Has a guy wire as opposed to a gal wire. No, a guy wire, you ever seen the telephone poles and they have these little wires coming out the side, and it keeps them straight, basically keeps them from falling over in high winds and things like that. Those are called guy wires. People think it's a guide wire. It's not a guy. It is not a guide wire. It is a guy wire, a male wire. It is 107 feet long, and it's attached to the top of the pole. So it goes here, and it's 107. You can just draw it any old which way. 107 feet long. That is my guy wire. Here's my telephone pole. What does the guy wire make with the ground? Well, yours will say it correctly, but mine should say what angle does the guy wire make with the ground? I will correct that before I print yours, but what angle does the guy wire make with the ground? So it's asking for the angle. Well, let's go ahead, before we even address that, let's talk about the fact that this pole is not leaning because it has a guy wire. And that makes this a right angle. What angle does the guy wire make with the ground? Is that here? No. Is that here? Yeah, clearly. All right. Let's go. This is opposite. This is hypotenuse. Opposite, hypotenuse. I think you know what that is. That would be sine. Now, your angle always comes after your trig function. My angle is unknown. Because my angle is unknown, well, I called it a Greek letter for one thing, doesn't have to be, but because my angle is unknown, I will need to do an inverse trig function. So 70 divided by 107. In the calculator, we will type this. 70 over 107, and it's going to tell me what angle that is. While I'm typing that, let me tell you, the cool thing about this kind of stuff is knowing that you have a right triangle, knowing any two other pieces of information other than the right angle, you can figure out everything else in the triangle. It's really cool. So like if you knew the height of a pole and you could measure the angle that the guy wire makes with the ground, you could find out how far away that guy wire is from the pole. You could find out the length of that guy wire. You could find the angle that it makes at the top. You can find all kinds of stuff. If you knew just two pieces of information, you can find everything else. And it's really handy in construction and engineering, things like that. 70 divided by 107 is, oops, there we go, sine of that, or inverse sine of that. This angle is going to round at 41 degrees. There we go. We are done.